Everyone, August the 10th. All right, let's do this. Coin change. You're given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the number of combinations that make up that amount. If that amount of money cannot be made up by any combination of coins, return 0. You may assume that you have an infinite number of each kind of coin. Answer is guaranteed to fit in a 32-bit integer. 32-bit integer, that's int. Because we are going to use Java. All right, amount 5, so 4 different ways to make the amount. 3, coin 2, no ways, 1 way. All the values are unique. So basically, we have coins, 1, 2, 5. So we can ask, if I take 1, right? So I always do, so DP will be index and remaining. How many different ways I can make, right? We take 1, or we can take a 0, 1, right? Or take 1, or take 2, or until we cannot. Okay, let's try this. All right, so first of all, we need to do a memo. And that memo is going to be, I think I would just use hash map will be the easier, right? Because I have 2, one is index, and the other, you know what? I think it's fine. We can do int. It's different ways, right? So this memo. Okay. Then here, we can say int n equal to amount. I don't need to do yeah, we can say amount. No, not amount. Coins.length. Okay. Memo equal to new int. So so if dpi is going to be, I is going to be the index. So we have n is here. Then we have dp also, the remaining is the amount. So it's going to be amount plus 1. Okay, so we get a memo. Then we're going to say int dp. Yeah, we're just defining side. Int dp, we're going to say index. So int index and int remaining. This one will return integer, right? Wait, hold on. Oh, I guess you cannot do that. I am not sure. Can I do it this way? Can I define a function inside another function? Java. Define a function. Yeah, you can. I think I asked this question before. Oh. Yeah, let's not do it this way. I think it's not how Java is supposed to be written. Yeah, that's fine. We'll do it outside. Do it outside. So private int dp int index int remaining, right? Again, if we need to do integer. And then I can say if memo, right, index rem is not equal to null, then we just return memo index rem. Otherwise, if what's the end? If remaining is equal to 0, well, if index is, because when we keep moving on, right? When we keep moving on, we will move on to the next index, but the index doesn't really matter, right? So so if remaining is equal to 0, yeah, because we will make sure that we will not go below 0, right? If it's equal to 0, then we'll return 1, right? That just means we have one way to do it. Yeah, if remaining is equal to 0, then that's one way. Okay, that's one way. And if index is larger equal to memo dot length, right? If index is equal to this, then return 0. This just means remaining is not 0. We have something remain, but my indexes are, I already used up all the coins and still have something remain. So this is, there's no way, right? In this case, there's no way. Okay, so now we can actually do the current. Then we can say for int, actually not for, the number of times we can take, right? We can take I, can take from 0, 1, 2, 3, until what? This 4, int I equal to 0, I times, shoot, I need int coins times coins index. No, hold on. I times this if it's smaller or equal to remaining, right? I plus plus. For each one of them, index equals this is always false. Why? Why do you say this is always false? Just keep going. Right, so we're gonna say if I take however many and I have however many, so this is like however many, so we have to have a int result equal to 0. Okay, so res or plus equal to dp index plus 1, right? Index plus 1 remaining minus I times coins index coins, right? Oh, I see. Wow, that's actually quite good. Yep, you're right. I should put it here. Oh. Yeah, res equal to 0, then we'll plus equal to I take however many ones, right? I take however many the current index. Now I take, right? Then we go, and once we have too many, that will come out, and we'll return set memo index remain or equal to res, return res. Does it make sense? Yeah, we take current, we take 0 current, or 1 current, 2 current, or however many until I run out of remaining. But it will never, the maximum will be 0, and next time will be 0, and it will give me 1. Yeah, so we do this, and then here I can call it, I can call DP, right? I want to say, starting from 0 with amount left, how many ways? I start from here, how many ways we can do? Then we can return this. Okay. It's like every time I mean right now when I write Java, it's always very, cautious, very careful, and try not to make things wrong. And we still got wrong. Dude, I don't want I don't want to do this part. That's okay. That's okay. So we have amounts, right? That's fine. We'll do yeah, it's actually it's fine. We just do this amount. That's just the first one, so we got the first one wrong. And this is going to be coins is okay. Right now we are just going to use one of them. It'll be 1, 2, 5. Answer shall be 4. Okay. Solution. This. Let's now search. Change. This is going to be amounts I. Coins is I. It's not a boolean value. Int. Yep. What do you think got wrong? Well, let's debug this, right? Let's debug this. I put at the DP and run debugger. All right. So first time run this. Index is 2. Wait, what? Index is already 2. Memo. Memo index is 2. So, oh yeah, because I 0 passing in, you go 2 and you go 5, right? Go 5, 0, 1, 2. So index is 2. I set 2 2, 5 with 5 remaining is 0. That's not right. That's not right. I is 0, right? And then index is 2. Okay? So 0 times 5 is 0. 0 smaller. So we go in here. Plus equal 1 becomes 0. That is true. Right? Then I do 1. Right? I become 1. good. So I think this one shall go first. This one shall go first. Yep. I think this one shall go first. All right, let's take this off. Terminate this. Go back here. Try to run it. There we go. So a small change. We have to check this one first. Yep. I think this one's right. Python, 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 Python. Ugh. Terrible runtime. 8%. How? How? Well, it just means it's not optimal. DP index remain, find the total number of ways to form remain money using coins index to the end. O(n) times coin times amount. I don't know. I mean, we can check our previous solution. 2022, that's about a year ago. Yeah, back then it's 28 test cases, 28 test cases. Oh, something is not right, I think this is also the regular DP. I think there's a better way to do this. Maybe we can, I don't know. Maybe we can do some pre-processing. Do you think it's the pre-processing that's making the difference? For example, if everyone in coins is bigger than the amount, then that's impossible, right? Yeah, but that's just like a very small thing. I mean, we can do here, we say, if the smallest, I would say if amount smaller than, find a minimum of coins. How do you find minimum? I think it's I forgot. Java array min. Collection? I don't think we can do this way. Yeah. This is another way to go. Yeah, it's stupid. There gotta be a way, man. can't remember the way, basically. That's why. What did they say? Apache Commons. Cannot use that. Streams. Oh yeah, I remember that. So it's gonna be ugly. If amount is smaller than arrays dot stream coins dot min dot as this, right? If it's smaller than that, and it says it's not right. Get this. What? Without present is present check. Nah, screw you, don't worry. So that's what returns 0. Basically, I just want to do a little bit pre-processing. Let's see, I mean, maybe pre-processing is how we get it to run faster. I doubt it. I doubt it. Oh, shoot. That's right. Ugh. Ugh, that's ugly. No, that is not right. I thought. Oh, yeah, you know what? Nah. Don't do this. I don't know. What was the good way to do? That's the same. It's just bottom up. This is the same. Java. If amount is 0, if this, then this. Int coins. Oh, that's an interesting method. Alright. Alright. Yeah, this is wrong. I do know, it's fine. Oh, look at this one. If coins I is larger than amount, that is true. And this equal to number of ways. Oh, interesting. Yep. I amount minus coins I. So like I take. Yeah, it works. It works. But I don't like it. I like this way better. But this is interesting. Yeah, but you have to erase the fill. Nah, I don't want to fill. So I use integer, which is fine, but this is a cool trick. Coins. This is a cool trick. So I can do this. I mean, I don't even need this. And I think I only use it once. So this can just be coins.length, right? And then this dot coins equal to coins. And then I don't need this one anymore. Right, and so I don't need this. all of this has to be this dot coins, right? This dot coins, and this is also this dot coins, and this one I can remove. Yep. Oh, you don't have to say this dot coins. You can just directly. Interesting. As the parameter of the method. No, that's not right. So yeah, we don't need this. Directly coins. Yeah, because you never use this to call memo, so you don't need that to call this one. Okay, so this is update. Use make coins a field of the class. Thus, don't have to pass it to the DP function. Yep. Now, I do not like bottom-up, because I feel bottom-up is, I mean, yeah, if you think bottom-up this way, I think it's okay, but it just takes more time. How would you do bottom up? Like in your way. Ugh, I hate bottom up. So bottom up, I'll say, I'll take this and I'll get the remaining, right? I'll get the remaining. So I'll say, if I want to do bottom up, if I'll do bottom up, because I need index. Index will be the rows, right? Index, this will be index. Yeah, index is the rows. And then remaining is the column. So if I want to find index, like say if we have everything else, and then I need to find index, so let this cell, right? This cell, index remaining. How do I find that? Which means we are, now we can fill this way, right? We can fill this way. So it will be the same way of thinking. We want to do index remaining, all right? So I take one index, then we always need to go the next, yes, we always need to go the next one. So we need to fill up the last row first, right? If we fill up the last row first, then I can do every single one, because everyone will call something at the bottom. So how do I fill up the last row? What's the last row? The last row is the last row is going to be a DP with 0 equal to 1, and everybody else is 0, right? So the last row is going to be like this. This is a 1, right? And then this is going to be n minus 1, right? Start from here. So you're here, then you will say this plus 1, which basically is just this one, and the remaining, right? Yeah, remaining. So with this, plus you take 1, take 2, so basically take everything, and then you'll get this value. And next, you'll check this one, right? I'll check this one. Again, you'll say, okay, I have the index. I will take 0, which basically take this one. Now remaining will be, yeah, remaining will be this thing. Yeah, this is the current remaining. then you'll take this, then you say, okay, I'll take this, or everything. Let's get smaller, smaller. Yeah, we can do bottom up. Let's try bottom up. Don't like it, but it's for the interview purpose. But we have to copy this one first. Okay, let's do bottom up. We will cancel, confirm. All right. Okay, so this will be bottom up DP. Okay, so int DP, now int this DP equal to new int length amount plus 1, and then DP0 will be equal to 1. So we can say this is edge case, which means when amount is 0 and there is no coins, we have one way to form. Okay, then we say for int I equal to coins dot length minus 1, I large equal to 0, I minus minus, because we go from bottom up, right? Then we'll say for int j will equal to amount j large equal to 0, j minus minus. Okay. So for each one, right? For each one, I need to, actually, that's not quite true. J is equal to amount, okay? Oh, for, no, remain equal to amount. Then for int j equal to 0, coins I times j smaller equal to remain, smaller equal to amount, then j plus plus. Alright? Smaller equal to amount, j plus plus. Then we don't need remain. Then what we need to do is say dp j, right? Well, plus or equal to we'll say answer int res current count, okay, to 0. Now we say current count plus equal to dp something. Well, it's gonna be I plus 1 and amount minus coins I times j, right? This will be the amount. So we go through all of them, right? We go through all of them. Amount minus coins I times j. That's the number I can take. Now when I take it, I go to the next level. So I do that. Once I finish, I say dp j, no, dp j. Wait, hold a second. This is not right. We're at the current, right? We're at the current we are at the amount. What we want to do is to find out with j, with I, right? Given that, and then different remaining, what's the result? Different remaining, what's the result? Yeah, different remaining, what's the result? And how do we find that? We say J is the count. Amount minus is this. So this shall equal to, yep, hold up, that's not right. That's not right. This is not right. dp amount minus, no, dp, amount, right? And then we'll minus this, so I'll get, so I take 1, take 2, hey, hold a second, this is not right. We'll take each amount, okay? We'll take each amount. But we'll say, starting from index I, given this amount, right? Starting I, given this amount, how many different ways? Then we'll go through different j's, right? We'll go through different j's, and I'll fill it up. And then we have a different amount. Then we go through different j's. So I do think we have to, yeah. So for int remain equal to amount, remain larger equal to 0, remain minus minus, then for j and j smaller equal to remain. Right? Smaller equal to remain. For remain larger equal to 0. Okay, hold on. And I shall be able to take at least, well, we can take at least I times coins int current count equal to 0. Okay, so current count plus equal to remaining minus this, right? Remaining minus this. Yeah, that's the current count. Because I have this amount remain. And now I take 0, I take 1, take 2, until I cannot take. And now I'll get it. Then, once we're done, we will say dp remain equal to current count. So we go through this entire thing, right? We go through this entire thing, and then I feel like this one can take multiple times, right? Then we return dp. Amount. Is that right? It looks to be right. Okay, but that's probably not the... Hold up, I don't think that's the right... I think the official solution is easier than this. So it has only 2 false. I have basically 3 false. So what it's trying to say is, we'll do this, right? We'll do this, and we say if coins, if it's larger, yes. Okay, we say if coins I is larger than remaining, right? Then we cannot take it. Then we say dp remain shall equal to dp remain. So if it's smaller or equal to, or if it's equal to, well, hold on, if it's smaller or equal to, right? If it's smaller or equal to, then we say dp remain shall equal to I take one. Huh. Yeah, so the next one, okay, next level, or the current level. So I have to go from front to back. Ah. So remain equal to 1. Because remain is 0 is always going to be 1. So, yeah, I do 1. This, say, smaller equal to amount. Yeah, this plus plus. And if it's smaller, right, then that shall be dp remain. I take 1, right? If I take 1, then the result shall be the remaining, which is dp plus 1, I plus 1, right? So be the remaining minus coins. Hold on. Ugh. If I take 1, right? If I take 1, so it should be 2 situations. Either we don't take, right? either we don't take coins I. If we don't take coins I, it's just going to be this, right? If we don't take plus or take 1 coins I, dp remaining minus coins I. Okay, this one right? Yeah, this one's right too. I think this is the start from coins I. The remaining start from coins I. Why? Oh gosh, that's correct, because every time you're adding the same thing. You are adding the same thing, right? Yeah, so if this, oh my goodness, that's right. Bottomup DP 1D from the official solution. Very, very neat. Yeah, I should start from coins I, because if it's smaller than coins I, right? If coins I, if rem is smaller than coins I, we don't do it. So we start from coins I, and then if we start from coins I, oh god. Understand this, write the DP in 2D form first, right? Then, because everybody will have to add this, so yeah, we can just plus equal to. So remain minus this. Will be this equal to this plus this. Next one will be this plus this. So yeah, it'll be plus equal to. Oh gosh. This is marvelous. Three milliseconds. Holy crap. So my initial solution is actually not correct. It's not technically. Yeah, this is not. This is worse than on times amount. Yeah, this is worse than, because I have this thing. You have to go through all the states, and each one you have to also go through this. So it's worse than this. It shall be this. Alright, let's do a top-down with a better solution then. Let's go copy this. Alright. So this is top-down. Top-down with better solution. We need to change the DP condition so that there is no additional loop in DP. This is fine, this is fine, this is fine. These are all fine. Here is not fine, right? So we can say if coins index is a lot larger than remaining, then memo index rem shall equal to dp index plus 1 remaining. Right, straightforward. Else, then memo index remaining shall equal to either take coins I or not, right? So if we take coins I, we have remain minus coins I left, right? But we need to still dp from I, because we can take multiple i's. If we don't take coins I, then we go directly for dp for I index plus 1. So that shall be dp index rem minus coins index plus dp I index plus 1 remaining. And we'll return memo index and the rem. Okay. Okay. Try this. Yep, this is the right solution. It's faster, right? It's faster than the other one. The bottom up is the fastest. This is a true n times amount. Yeah, this is the DP condition is, you should do it again. Yeah, you should do it again. You shouldn't do another array here. That's fine. Hopefully I can learn about this. It's 4 different solutions. 2 kind of bad DP and 2 better DP. Okay, that's enough for this one. Move on. Okay, it's an easy one. Given positive nums representing a string, return the integer num without trailing zeros as a string. Without trailing zeros. That's actually a good practice for the Java skill. I actually don't know. Maybe I should go from right to left. Every time I find 0, I reduce the size. And once I'm done, I do a substring. Okay, so Java, how do we... Java get substring. How do we do that? Substring in Java. It's a function. It's a method. str.substring10. Begin index. The begin index inclusive. Ugh. Can we get a end? End index. Oh, I said begin and I said the end. Is it inclusive? With a character at a specified index and ends to the end of it or up to index -1 if the second argument is given. End index -1, so it's not inclusive. Okay, 10 to 16. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, hold on. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Isn't that empty? 11, 12, 13, 14, 15, 16. 16 is F. So we don't include, okay, geeks. Yes, yes, we include this. All right. So we use substring. Okay, we use substring. Straightforward, we go substring. We are going to go int len equal to num dot length, and we say for len, this len, hold on, num len minus 1 is equal to 0. Len minus minus. Oh, holy crap, that's it. Then we'll return dot char at. My bad, I forgot it has to be char at. Has empty body. Yes, that's exactly what I want. Now I'll return num dot substring 0 to len. Is all right? Yeah, it looks decent. Hold on. Get something in the front just in case. Doesn't have any leading zeros. What? What is this? Doesn't have anything to do with this. Oh, hold a second. Maybe there's a function. Java. Strip. Trailing zeros. Ugh. Regex. Oh, regex. Yes, yes, let's try regex. Let's try regex. Yes, yes. Suddenly realize we can try regex. Can try regex. Hold on, let me do this one first. Okay. This, what question is this? 2710. 2710. Not pi, it's Java. Hold on. Hold on. Still getting used to the ID. Okay, so that is solution 1, right? That is solution 1. And I can do solution 2 using regex because I can do replace. Hold on, how do we do this? Oh, no. This. Okay. So I can say num dot replace. Num dot replace. Right? And replace. Wait, do we need replace all? Hold a second. Do we need replace all? Replace. Oh my god, replace first. Wait, how do we do this regex? Yeah, exactly. How do we do this regex? Because regex is to find something. How do you do regex? Replace. This is to replace first. Trailing zeros. I can find the first zero, right? I think that's possible. I can find the first zero and I can replace it. Replace with, let's say, empty. Yep, how, I don't know. Oh, all of them, replace. Hold on. Replace all. Okay, so when you do a regex, I can do a regex string. What I want is, because it says there's no leading, right? So it got to be this. Oh, sorry. So it got to be this. Right? Some integers, right? Then I find wait, hold on, but you will find I'll find first this, right? I'll find this and with 0, right? Plus. Does that make sense? Hold on. Yeah, you use regex, you're creating new problems. But I have a tool to help with the regex. So what do you want? I want to see if this is right. I find the first group is this, and the second group is going to be maybe that, right? 0 matches the character, 0 matches 1. So if I do 1, 2, 3, 0, 0, 0, it matches, right? It matches the group 1. Ooh, that's not right. So can I do none greedy? Is that do this? None greedy? Huh. That's not what I want. As few times as possible, right? As few times. So now I have match 1, match 2, match 3. How do I match? How do I match? I want to match everything up until 0 towards the end. Maybe I can do also say towards the end. I do the whole match and then group 1. Yes, that's the one. All right, that's the one. If I don't use this? No, I have to use this. All right, that's the one. Because I match group 1, I match the whole thing. Basically, I'll match the ones that's not the trailing zeros. And then I will replace, I mean, for better or worse, we can probably add this into it just to emphasize. So here's what I want to do. So I can do this, I'll do this, and I will replace with I saw them using it, so I'm not 100% sure. This probably need to do this. Escape it. Result of this is ignored. Well, I'll return this. Okay. All right. Let's take a look. regex. This one works. Oh my god, I think it does. I think it does. Alright, oh. It's slow. It's so slow. Regex. For fun. But it's so slow. Don't use regex, right? It's fun, but don't use it. And depends. I mean, it's just a tool. Depends on what situation we're at. Sometimes regex is the best option. Sometimes it's not. All right, man. Doing Java does slow me down tremendously. I can only do like 2 problems. All right, that'll be it. I need to eat. I haven't eaten yet. I will see you guys tomorrow. Adios.